Okay, this is Tuesday, September 5th, and today we're going to be talking about parametric curves. So I'm going to share the screen. And hide the console. Right, so we started a notebook with a title of Project 2. And part 1 of Project 2 is called Illustrating Curves. Or we should say illustrating parametric curves. Illustrating parametric curves. And the basic format for plotting a parametric curve is to use the function parametric plot. And parametric plot, in its most basic application, takes 2 arguments. First of all, the parametric function, which is 2 functions of a single variable enclosed in curly braces to denote a vector, a position vector, and then a specification of the variable, t, and the domain of the variable. And when we input that, we get a picture. Looks like this. I'll make this a little bit smaller. Now you can do interesting things. For example, we could modify the function, and we get other interesting pictures. There. See, so these are various parametric curves that we get from different by putting different coefficients in front of the argument. We're going to be working with parametric plots in 3 dimensions. So let's take an example of that. Parametric plot. And if we're going to plot in 3 dimensions, we have to write parametric plot 3D. And then the argument needs to have 3. We need a space, a position in space. So we need 3 coordinates. And let's do the function that we have in the homework that I will be giving you a link to. The second problem, number 32. Well, all right, problem 32. Let's see here. Maybe I should make this. Problem 32 asks us to plot the function whose coordinates are t squared, log of t, and t. Now, in Mathematica, log, right, the natural log is written log. And t, oops, all right, that's the function. And they don't tell us in the problem what domain to use, or rather they say, use a computer to graph the curve with the given vector equation. Make sure you choose a parameter domain and viewpoints that reveal the true nature of the curve. Okay, well, we would have to go from, right, the log of 0 is undefined. So we have to, and the logarithm of negative numbers is undefined. So we have to start out with a small positive number. So let's maybe start out with 0.2, and then we'll go to 2. And there we get a picture of the curve. Now, when you produce a 3D plot, when a 3D plot is produced, you get an enclosing box that you can manipulate. You can turn it by clicking and dragging. And that way you can get a good sense of what the appearance of the curve is. Now, that's quite simply what you need to do for this first part of the project. The homework will give you a list of several curves, and I want you to plot them. But here's the thing that you can do. We can plot several curves at once. So we might want to see the projections of this curve onto the different coordinate axes. I mean, into the different coordinate planes. So the projections into the coordinate planes are going to be seen by setting one or the other of the coordinates equal to 0. So this will create the projection of this curve onto the YZ plane. This creates a projection of the curve onto the XZ plane, and this creates a projection of the curve onto the XY plane. And we're going to plot over the same range, and we'll take a look at this. Now we see here that there are 3 curves that we see. Right? There's the colors come in order. So the colors come in order: blue, yellow, green, red. You get used to the order in which they come as you work with this. So we've taken the 3D curve first that we see in blue, and then we have the projection onto the YZ plane that's in yellow here. So we can see that there. And then the projection into the XZ plane that is in green. XZ. So this is the X direction, and the vertical is the Z direction. And then the projection into the XY plane is in red. Now you can't see the planes in this picture. Also, your eyes can create like these when the shape is not in the right position, your eyes can create your perspective can get confused, and you don't know if you're looking from the back or the front. Right. So it should look like that enclosing box should look like a box, not any other shape. And if it doesn't look right, then manipulate it until it begins to look right. Okay, so this plane, the yellow curve is in the YZ plane. So this Y is going this direction, Z is going this direction. The green curve is in the XZ plane. So X is going in this direction, and Z is going up and down. And the red curve is in the XY plane. And you don't need to do this if you don't want to. I mean, you can, right? You can do this with other functions, but it's not necessary. Let's take another example. So that was the basic example. Okay, let's take a step back here. I'm going to share the entire screen so we can also see the assignment. The problems that I want you to work on in this fashion are problems 31 through 38. 31 to 38. This sheet of problems is accessible in the Moodle. I say problem 32 extra. You can do extras for various problems too. These headings, all right, this heading here this is the headings that I'm making on the problems. I'm doing that by choosing to make them subsections. I'm going to show you another thing that we can, another thing that we can do here. Copy. I guess the extra goes not there, but here. Let's, I've shown you manipulate, okay? Manipulate. So we could manipulate a parametric plot. And let's go back, just do this simple, just the one curve. And if you are unsure of what region to graph it over, we could select a region, manipulate the region over which to graph it. So we're going to, let's say, let A go from 0.01 to 1. And let's let B go from 0.5 to 3. And then we get a, depending on what domain we choose. So this is a domain, you can see the value of A and B here. So this is graphed from some point near 0 to point near 0.5. If we graph it over a larger domain, it expands. And if we trim off the first part of the graph, it expands. We could also choose a fixed plot range for this. So let's think about what plot range would make sense. So there's the arrow. And we need to specify the plot range for X, Y, and Z. So the first coordinate is t squared. So that's first coordinate is obviously going to go from 0. And maybe if we go up to 3, let's go from 0 to 10 for X. For Y, it's the logarithm. So let's start from -10, and we're going to go up to, let's say, at most 2. And for T, the last coordinate, let's let that go from 0 to 3. So now we're going to have a box of fixed size and shape, and we're going to see the curve in that box, and we can adjust where it begins and where it ends. Now, what we don't see in here is the coordinate system. So we could add a coordinate system. So let's do that. And so to add a coordinate system, I'm going to build it in graphics 3D. And I'm going to make a line. Let's make a red line, right, from the origin. From the origin, 0, 0, 0 to 10 or to, let's say, 3, 0, 0, comma 0. Let's make a green line. A green line and a blue line. And we'll make a green line in the y direction. So we're going to go from the origin, and y is going to be as big as, well, let's make it go out to 2. And, oh, actually, this is the, I should put this one here. So in the x direction, x goes from 0 to 10. So we'll go from, and my z coordinates go up to 3 because t is in the last one. So what I've done here is made some graphics 3D, right? And if we look at the graphics 3D here, we get these coordinate axes. Those are lines. We can make them arrows, perhaps. That would look nice. ARROW. Right. So those are the coordinate axes. So red for the x direction, green for the y direction, and blue for the z direction. Let's save this thing, okay? I'm just going to call it axes. It's saved, it's recorded as axes, and then I can add this to what I'm doing here using this the command show. So I'm going to write show, and I'm going to combine the two things, axes and the parametric plot. And now you see, right? Now you can see these axes, and there's a portion of this curve here that is got a negative. It's along this portion of the curve, y is negative, so it's to the left of that. But if I let the curve increase over here, you can see it, the axis in the background. All right, so what's new here? There's 3 new things. Well, let me tell you the new things that we've got. A summary. What's new? Let's make this text. What's new? First of all, plot 3D, parametric plot 3D. And that's the basic tool that you're going to use. And this is very straightforward. 2, plot range, the option. And 3, right? Graphics 3D. All right, so this just enables you to draw sketches in 3 dimensions. Right. You have 3-dimensional graphics primitives, 3-dimensional graphics directives, right? So you can create a 3-dimensional graphic object. And then the important one that could be useful to you is show. And show, right? Show combines 3D graphics from various sources. So when you're using Plot 3D, you're creating a 3D graphic, right? When you're using Graphics 3D, you're creating a 3D graphic. If you want to put the 2 different graphic objects together in one picture, you use show. And you just put those 2 graphic objects as arguments of show. You can use show. You can combine several 2D graphics in show. You can combine several 3D graphics in show. I don't think you can combine 2D and 3D graphics in show. Yes? Yeah. Plot range is an option. Yeah, plot range is an option for parametric plot 3D. Yeah, yeah. And the little arrow there is a dash and a greater than sign. Okay, so that's what I want you to do. All right, on the Moodle page, you can go to the Moodle page, and you can download this. You can find this. You can find this. These exercises. So project 2, part 1, and what we want to do in part 1 is do problems 31 through 38. From the Sullivan text. And I guess it was chapter 8, section 1. Was the next chapter's chapter 13, section 1. And this thing right here is not part of the assignment, but all right. So this, let's see here. Background. And then the problems here. My solutions. And again, let me say here, you just have to do the basics. You just have to do what they ask you in the book. But, right, I've given you a number of different embellishments, number of different ways you can go beyond what's asked for in the book. And I hope you will do that for some problems. It's not necessary, but it sure would be fun. Extra fun. Okay, now what I'm going to do is save this. It's saved. Yeah, we'll go back to it in a moment. Right. Where did I save it? Okay, I'm gonna stop the video now.